D and L monosaccharides. Why this D and L letters are used for the monosaccharides, that we are going to decide. Now to understand why D and L letters are used for the monosaccharide, you look at the structures of glyceraldehyde. So this is R glyceraldehyde, or naturally occurring glyceraldehyde R, which is having just one chiral carbon. It is represented in Fischer projection formula, and you know, in Fischer projection formula we just draw one vertical line and one horizontal line to show the chiral carbon. So this is a chiral carbon. Now if you consider here a mirror, its mirror image is this one. This is S glyceraldehyde, which is actually non-superimposable mirror image of this structure. So this is enantiomers, or these are enantiomers. Now you can see here OH group is toward the left hand side, here OH group is toward right hand side. So if the OH group is toward right hand side, so this D is used. So this is D glyceraldehyde. So R glyceraldehyde is again D glyceraldehyde, and S glyceraldehyde is a L glyceraldehyde. So these two letters are used to show the configuration of the chiral carbon. So this is D glyceraldehyde and L glyceraldehyde. Now to provide D and L letters to other monosaccharides, we have to represent that monosaccharide by using Fischer projection formula. In Fischer projection formula, we draw one vertical line and other horizontal line to represent chiral carbons. So here I have taken one example of glucose where 6 carbon atom present, and you can see there are 4 chiral carbons. To represent 4 chiral carbons, we have to draw one vertical line and other horizontal lines. Now these are the chiral carbons. Now how to provide D letters or D letter or L letter to the monosaccharide? You just watch the chiral carbon which is away from the carbonyl group. So which is away from the carbonyl group. So this is a carbonyl group. So as we move away from this chiral carbon, so this is the chiral carbon which is away from the carbonyl group. So the terminal or the last chiral carbon is considered to provide letter D or L to the monosaccharide. Now once this is fixed, once this is drawn, you have to just compare the configuration of this last chiral carbon which is away from the carbonyl group with the glyceraldehyde which is like D or L. Now you can see here this is like D glyceraldehyde because OH group is toward right hand side, here OH group is toward right hand side. So it is like D glyceraldehyde. So because of this, D letter is written to this monosaccharide. Since this is glucose, so this is D glucose. Now this is the again enantiomer of this glucose. You can consider here mirror image, and you can draw one structure that is non-superimposable mirror image. So this is enantiomer. Now consider this is chiral carbon, chiral carbon, chiral carbon and chiral carbon. So we have to consider the chiral carbon which is away from the carbonyl group. So this chiral carbon is away from the carbonyl group. And now compare this, the configuration of this chiral carbon with the D and L glyceraldehyde. You can see here OH group toward the left hand side just like L glyceraldehyde. So because of this, we have to provide letter L to this monosaccharide. So this is glucose, so this is L glucose. In this way, you can provide letter D or L, capital letter D or L to the monosaccharide to represent the configuration at the chiral carbon which is away from the carbonyl group. But there might be some confusion. I must clear that confusion because in carbohydrates we use either D and capital D. So this D and this D are actually not so much related. So this D means dextrorotatory and this D shows the configuration at the chiral carbon which is away from the carbonyl group. Similarly, if this L and this L, you can you try to understand this L means levorotatory and this L means the configuration which is like L glyceraldehyde. So in this way we can show the configuration of monosaccharide by using D and L letters. Thank you.